to be here to introduce the work cooperative. The topic is fiber-specific wet matter reductions in multi-cognitive impairment. The MCI is the preclinical stage of AD. Early screening for MCI could help to reduce the risk of AD. According to biomarker modeling of AD, the time sequence is shown in the figure. Here we can see the A-beta and the P-tau deposit as the earliest biomarkers, but they are invasive and costly for preliminary MCI screening. So MRI for structures are non-invasive biomarkers, and wet matter is an effective biomarker. However, what and how the wet matter fibers degenerate during MCI remains largely unclear. Previous researchers focus on the limbic system, but unlike whole brain wet matter reductions in AD, wet matter reduction first appears on specific tracts in MCI. Besides limbic system during MCI remains largely unclear. Therefore, a more targeted approach to obtain wet matter templates for MCI is needed. The main symptom of MCI is the memory loss. The hippocampus is a key hub for memory processing in the limbic system, and there is plenty of wet matter that connecting the hippocampus to the temporal lobe. Therefore, we hypothesize that the hippocampus temporal fiber tracts play a crucial role in the wet matter reductions of MCI. The DTI can detect subtle structure changes in wet matter fibers. The index FE and MD reflect fibers' wet matter integrity. Our study aimed to identify the wet matter reduction pathways in MCI and provide novel biomarkers for the early diagnosis of AD. Previous researchers focused on the limbic system with existing templates such as JHO or SABM. In our method, regions of interest that had high correlation of resting state functional connectivity MRI with the hippocampus were selected as states to track fibers by DTI. 3 ways to verify the novel biomarker: drug sum, statistic analysis with FDR, machine learning, and presence correlation. Here's the flowchart of resting state functional MRI data driven method for fiber tracking. And here's the details for the image acquisition and the pre-processing. And then the statistic analysis. For the result, here's the characteristics of MCI and the groups. For the result, we take the mean diffusivity as an example. Result 1 showed significant fiber tracks from resting state tracking in MCI by comparing with NC. Figure A is the hippocampal temporal fiber tracks made in our method. Figure B is the limbic fiber acquired from JHO and tablet. Obviously, the hippocampus temporal fiber tracks are more effective biomarkers for MCI. Moreover, the only significant fiber tracks in the limbic system, the pharynx and the ATR, connected the hippocampus. Result 2 and result 3 we can get the same conclusion as result 1, that hippocampus temporal fiber tracts are effective biomarkers for MCI. The contribution of our study is that hippocampus temporal white matter fiber reductions occur during MCI compared with limbic fibers. Our research provides novel biomarkers for the early diagnosis of AD. The DTI fiber tracking driven by resting state functional MRI is a more targeted approach than JQ or SABM template. The group difference SVM machine learning Pearson's correlations are proved hippocampus fiber can be an effective biomarker for MCI. For this study, special thanks to 3 mentors and these administrations and foundations. Thank you for your attention.